Hello everyone, today I'd like to present the results of work on our project The Smaller the Better, Heterogeneity of Corpus, Training Size and Morphological Tagging. At first I'd like to describe briefly a problem that this article is devoted to. As you can know, historical texts are extremely difficult for tasks of post and morphological tagging because of their orthographic and morphological heterogeneity. There is the same problem for historical texts in pre-modern Slavic. There are some modern approaches that show the state of the result without normalization, which is very important because normalization is one of the most difficult steps in the whole task of post and morphological tagging. But these existing approaches are still very sensitive to the properties of training data such as genre and origin. So our goal was to investigate what extent the heterogeneity and size of training corpus influence the quality of post-tagging and morphological analysis. We observed that UD pipe trained on different parts of the Middle Russian corpus demonstrates a boost in accuracy when using less training data. The smaller the better? There is a question. We resolved this paradox by analyzing the distinction of post tags and short words across subcorpora. So let's move on. And for this study, we conducted a set of experiments on the material of the Middle Russian corpus of RNC included in the collection of historical corpora. The Middle Russian corpus consists of 5,673 historical documents from 1125 to 1731, and there are more than 8 billion tokens. All the documents were segmented and annotated for parts of speech and morphological features according to the UD schema. Most of the texts were created or copied from the 15th to the 17th centuries. The corpus texts belong to a large variety of genres. For our study, we reduced them to one of the following language register types. There are several, as you can see in the table 1. So, official, business, colloquial, Church Slavonic, and hybrid. Hybrid means a combination of Church Slavonic and colloquial speech in one document. Some texts were assigned to more than one type, mixed. Table 1 shows the text and token distribution by the register. And both distribution are biased toward business and hybrid registers. We used UD pipe, a trainable pipeline designed for tokenization, tagging, lemmatization, and dependency parsing. The default settings concentrating on the influence of training data, changes on the accuracy of tagging were used. We extracted text samples in 3 different ways to prove 3 different hypotheses. So the first one was a question: whether the training data affects the accuracy of the model. Several samples were extracted from the original corpus containing from 5 to 100% of the training data set. Models were trained on these samples and compared. Our second goal was to analyze the effect of time homogeneity on the model performance. To examine our second hypothesis, we took 3 samples that contain text from the 15th, 16th, and 17th centuries. One more way of sampling is to normalize by sampling size. This size contains text from all 3 centuries. The sample size is 1/3 data for the 16th and 17th centuries. The model trained on this sample should approve or disapprove the efficiency of the middle way approach based on an intuitive view on historical language non-homogeneity. To train a universal model, a universal sample containing every possible deviation from the prototype should be used. So, as for method that we've used, as it was said before, we used UDPipe with default parameters. Data sets were extracted from the Middle Russian corpus containing text from different periods and of different sizes. And datasets were divided into two groups to check how the number of tokens in the dataset can affect overall quality, and to understand the possibility of creating a universal model well suited to work with language variety. Of course, mostly with the graphical and morphological heterogeneity. Here you can see some results that we've got. The first picture shows us size effect. Here you can see that the best accuracy was for the smallest training set size. So it's quite strange result. But still, there is a question. The smaller the better. Maybe this can be a special feature for historical texts. So let's move on. And we will know more about our result of post-tagging for the same models of different training data size. So the first model is 50% model and the second is 25% model. So we can see that results are pretty the same. However, although the models are different. And now we can observe the result for century-based models. And there is a strange thing. We've got the same result as before for models that were based on training size, that the smallest subcorpus training dataset showed the better results. So model that was trained on this the smallest dataset showed the best result comparing to the rest of models. So 15th century was the best. And there is also some matrices to show that mistakes are not the same, but amount of them is still pretty the same for 16th century model and 17th century model. So results are very confusing. As for post-tagging, which was considered as a main problem, so post-tagging was the most difficult for tagging short words from closed classes, which include determinants, particles, conjunctions, adpositions, auxiliary verbs, and pronouns. The models we trained confused these parts of speech with verbs and adjectives. The promotion of such confusion differs from model to model. As we see later, this can be explained by the number of particular post tags in different training sets. Our study showed that bigger doesn't always mean better. The model trained on 100% of the training dataset showed the worst result, while the model trained on 10% of the dataset showed the best result. This leads us to the conclusion that the general problem is overfitting. The universal model is not always the best solution. The model trained on century normalized text extracted from all 3 centuries demonstrated poorer results than the 17th and 15th century models, especially poorer than 15th century model. Despite the best models being obvious, we compared less accurate models to analyze some common mistakes inherent to all of them. This analysis allows us to list some of the most common problems and continue working on improvement strategies. To identify whether the controversial training size on model performance was caused by data bias, we randomly selected 5 more training sets, 6.5% of the corpus each. If our assumption is correct, we get similar result for each experiment. The gap between the best and the worst attempt is about 1%. This proves our initial hypothesis and shows that the training data set can negatively correlate with the model efficiency. We also examined how different models tag in vocabulary words and unseen out of vocabulary words. These results highlight 2 main trends in our models. The models trained on larger sets suit better for tagging out of vocabulary words, from 85% to 88%. But often cannot tag in vocabulary words correctly. On the opposite, smaller training size models show remarkable result in vocabulary words, but often unable to tag out of vocabulary words correctly. Taking into account that there are around 500,000 unique tokens throughout the corpus, we can now see where this significant gap in accuracy came from. Variations in orthography and grammar create a situation when the borders of the classes become blurred. It affects some of the most frequent post-text like verbs, adjectives, and nouns, so larger models become strongly dependable on their distribution in the training set. As the training set volume increases, a model is trained on more non-standard forms of verbs, adjectives, and nouns. It makes the model more flexible but less accurate. There is a reason why such models are good at tagging unknown words and at the same time overfits on frequently used words. So here you also can see various training set. It was about experiment about dataset 6.5% corpus each. So yes, and this table describes the accuracy of tagging in vocabulary and out of vocabulary words. Here, I'd like to make a conclusion. Although both tagging accuracy was moderate, the results seem to be promising. In future research, we plan to find the middle way between underfitting and overfitting. The fact that models trained on smaller datasets demonstrated better results shows that there is maybe an optimal data size or model of text sampling. So, thank you for attention.